Bismillah ar-Rahman ar-Rahim. Alright, I guess this is my very first tutorial I record in English for my channel. This tutorial is about methodological diagrams. It's part of ASU X48, an undergraduate research course delivered in Shams University. I guess the content for this tutorial is beneficial to anybody really working or starting to work in academia research, because a huge part of our work is visualizing, and I guess this is not like formal, it doesn't really have a format. I'm not claiming that this is like the best way to draft your methodological diagrams or anything. This is just the way that worked for me, and I kinda tried to formalize my process, and that's that. Yeah. So whenever you have any part of your methodology where you want to describe a process, you want to describe some procedure, some calculation that you had, you'd usually use some block of text, a paragraph or two, a page, something like that, to try to communicate as accurately and perhaps succinctly, if you can, what exactly have you done, for it to be replicable by other people who are reading your research. But sometimes, like they say, a picture paints 1,000 words. It really sells itself. So like, looking at this paragraph, and I give you a minute to look at it, if it's accompanied, I'm not saying you can replace it, you cannot replace it, you'll have to write accurately about your research, but if you accompany that with something that shows, okay, this is what I really mean, or okay, it's broken down into these steps, and for each step you have to do so and so, it gets kinda clearer. Another question is, if you are interested in making this type of figure, this is exactly the video for you. I'm going to talk about different aspects that go into developing this type of figure, and this exact figure I'm going to show you the process, the thought process that went into doing it, perhaps talk a little bit about its different visual aspects. So yeah, how can we make such figure? I'd say that any methodological diagram, and I'll call these types of, because these are not, of course, these are not the only visualizations that you have in research, but for this type of visualization that I am addressing here, which is diagrams where you explain a process, a calculation, or something within your methodology that you want replicable, and you want to elaborate further on it beyond your text, I'd say that these types of figures are divided into their back end and front end, or like the chassis and the engine, the mind maps and the visuals, I'd like to say, because the way to construct, even like I will not tell you that I started doing these types of graphs from a mindset of mind maps. I didn't start from there, but like, if you look at the concept of mind maps, I'll tell you, I'll try to convince you that it is the way to visualize such methods, or it is a way. This is just all the backend, the concepts, the actual thing that you want to communicate, because if you start from a block of text, you cannot really draw a block of text. You need to divide it, to break down the concepts and draw the relations between them. I'd say this is the aim of a mind map in this setting. And then after breaking it down into its components, visualizing the interactions or like relations between the components, the visual aesthetic of this is also as important, because if it doesn't look right, nobody will look at it. Okay, so like I said, I'm talking about what I call methodological diagrams, and we defined what this is. And the purpose of it, as is the purpose of everything in your like literature that you write. It's to communicate. You want to communicate something to your readers. In methodological diagrams, I'd say it's the relationship between different constructs. So you communicate the constructs and the different relationships between them. Beside the communication, drawing these types of diagrams will help you modularize your thought process, will help you make a more clearer narrative for your research, because you are breaking it down into its core concepts. You see what really are the core concepts, how they really interact with each other. You can play around, in a sense, with the concepts and see how they fit together or how they don't fit together. And mind maps, typically, like, they have been used for like note taking, for studying, in a sense. And yeah, for sure, that's one part. But also, you can use them for, like we said, breaking down the different parts of a central idea or of your central idea. And we'll have an example at the end. I know this, I don't know if this video will be long or not, but yeah, we'll have an example at the end. Mind maps usually start from a central idea, and from this central idea stems different grouped ideas or group topics. And grouping can be done in many different ways. You can group in a chronological order. You can group like if you are doing some debate, or if you're like talking about a debate, you can talk about pros and cons, like for and against, and perhaps a verdict. You can group with the different like stages. If you are doing an experiment that it has multiple stages, so you can your central idea is the experiment. You have the different stages, and each stage is broken down into its whatever processes, sub processes you have, and you can expand on this further with concepts, with keywords, with figures. Even like, I'm just drawing some ellipses. I'm not telling you to stick to ellipses. We'll talk about form and like visual contrast, but it's, you can do it with literally anything. And I'd say that mind maps are intuitive. It's not something new, even if you haven't used mind maps. If you have heard the term somewhere and then, yeah, whatever, I'll stick to what I'm doing. It's not the genius is not in it being intuitive, it's in regulating this intuition, I'd say. Because once you see a pattern that you can use to break down and then structure your thoughts, it will be helpful. And once you have this type of diagram, then we care about and we think about how to visualize it. But like, if you don't have any meat, you don't have anything really to preview, you'll just draw some fancy shapes. Okay, so graphic design. Why should we care about graphic design? I'll say that the main goal of a graph or a figure or a diagram is to communicate in a better way, or in another way than just plain text, or otherwise you just write your stuff, write your results, methodologies, and then that's it. Why do we visualize? It's a better way to communicate. It's a better way to sell our ideas. It's a better way to go through to the readers. So it's key. It's as important as the writing itself, because if your ideas does not go through, or do not go through, then who are you talking to? You are not communicating. It's like, it will not be published. The easiest thing to say here is, it will not be published. You will not be able to publish if you cannot communicate with the other readers. You need to know the readers. That's a topic for another day, but like, you need to know them and to know how to communicate with them. What language do they speak? What figures do they like? What things do they relate to? And then you relate to the same things as your readers, because you're writing for them. It's a different writing than writing to understand, for example. Same thing with visualization. It's a form of communication that's necessary for your research. Okay, so I'll talk very briefly about graphic design. I'll provide some resources at the end, just let me say that the key takeaway of this whole presentation about graphic design is consistency. You need to be consistent with whatever visualization scheme that you choose. Consistency is in colors, is in shapes and sizes, is in padding, is in the relations between the shapes. So compositional contrast, for example, compositional consistency, it's in every little part that you do. It needs to be consistent, and this will transform whatever figure you are doing into much better version of it. Okay, so there are very useful concepts from graphic design that we can borrow from graphic design while drawing our figures, while drawing, even while writing our articles. And we are already borrowing so much from graphic design. We don't really notice it. We don't talk about it because it's not our job. Our job is to write papers and cry about it. It's not to do graphics, but it's kind of our job to do graphics, because if you don't do graphics, you will not communicate well, for the most part, I'd say. So from these are visual contrasts. From the concepts of graphic design that are important to us are visual contrasts and, I'd say, typology and understanding denotation and connotation. I will not speak about this for now, but it's just visual contrast and typology. Visual contrast comes in very different shapes. It's literally shapes. So different shapes have contrast between them, scale, direction, or the space that the foreground background relation. So the relation of this very text and the background, the white background behind it. There is a contrast of weight between the title here and the different bullet points here on this same slide. There can be a difference of texture. There can be many types of visual contrasts that we can utilize in our favor, and I'm already utilizing it. I'm utilizing a weight contrast here. This is larger and heavier font. Both are Arial, but this is Arial black, so I'm signifying that this is the title. I'm using contrast in something, in a very familiar way to you, to convey something, to convey order or consistency, because this very same font has been consistent throughout the whole presentation, the title and the body. Both of them have the same font type and the same, I went ahead. Both have the same font type, same weighting, same font size. Now, let's go back or go forward to this blue-orange. This is an example of complementary colors. So colors can be colors fit together in different ways. It's a whole world out there. There are complementary colors, there are analogous colors, monochromatic colors. Understanding the different color palettes, or the existence of color palettes, the existence of colors that go together or do not go together, colors that can go well as foreground background, colors that can go well as a hue or a visual color palette for a figure or a graph. This goes a long way, because understanding that there are groups that work well together will help you make a good choice about which colors to use. And of course, the two different images show very different feelings, I'd say, or we perceive them differently, I'd say. We perceive them differently, both have different moods, and the colors within each of these images have different relationships with respect to each other. Okay. The other part that's really important for us from graphic design is typeface or fonts. And since we spend most of our life writing, there is nothing familiar than nothing more familiar, I'd say, than text, because we spend a lot of time reading and writing. So we can play around with typefaces a lot in very different ways. We can play with letter forms. So there are serif fonts like Times New Roman. There are sans serif fonts like Arial or Cambria. A lot of very different examples. We can play with the set type. We can play with the font size, type size. We can play with the justification. So how the text is aligned. You can also play with the spaces within the word, or the line spaces, the spaces between words or between the lines or between paragraphs even. Now, why should I care that I can play around with text? I'd say the reason is changing these properties of text or typefaces would give you different visual contrasts. So it conveys different visual images even as text. It's not a visual, it's not an image, but it's conveying something visual. Because think about it, you know there is a difference when you are reading a 2-column article, for example, and a 1-column article. There is some difference to it. That goes beyond the utility. For example, that 2-column page can have more text per page, but this is not the thing that I'm talking about now. There is a perception of how you perceive text. There is a way that you view text depending on how it is formatted. It's not just format for beautifying it. And your methodological figures would contain text. Most probably they would. And if they do, you have to also use text as part of your visual contrast. It's a graphical element as well as denotative of what you are actually talking about. It's a graphical element that you have to utilize in your diagram. So it needs to be consistent. For example, they all need to be, for example, same font size. If you are visualizing a flow chart, all the items in the same level should be of the same font size, of the same format. They should be in the same figure type, same box, for example, same colors, same consistent. They should be consistent. So understanding how to change stuff, first of all, will make you ensure that similar parts of your diagram are consistent, and you can use the contrast to emphasize the different parts, or to give emphasis to the different parts. Okay, so why should I care? Why should I care if it's not really formatted? Imagine this first introduction section paragraph. What's happening here? It's not in a bit consistent. So I have highlighted a couple of problems that even if we didn't have these, if you look at this, you'll feel that something is wrong. And it's good to have this feeling that something is wrong, because something is indeed wrong. Because the font size is inconsistent, the font type or the typeface is inconsistent. This is not justified. Most of your scientific literature that you are reading is justified. The heading is not stylized to anything. The margins, if you take a closer look from the left, is not equal to the right, which is also a bit unusual. So all of these different parts show an inconsistent image, which you can easily fix if everything is the same font size, same typeface, justified to the way that it should have been. Of course, each journal submission has each journal has its own rules, both for the like published proof and the draft that you are submitting, or the manuscript that you are submitting. You're not necessarily submitting your article the way it is published or it is going to be published. You may be writing with, for example, larger line spacing for it to be easier, more readable for reviewers. So it's depends on really the rules that you are sticking by, but there are rules and you have to be consistent with them, otherwise it looks weird. Okay, so these were all the concepts that I wanted to talk about regarding methodological diagrams. This is an example submitted by a student in ASUX 48, where I asked them, part of, just to give you some context, this course asked the students to search within a scientific topic of their choosing. They need to search literature, they need to select initially some literature, and based on their selection they need to start conceptualizing. Okay, what are the different parts of a literature review or a mini micro literature review that they are writing? This student wanted to write about the cost of concrete in construction. They wanted to convey that there are material factors, there are material factors, construction factors, and they wanted to look at different technologies and like machine learning models that are used for cost estimation, and look at the cost, actual cost of concrete in different like structural types. This is the figure. I'm not going to judge the back end of the figure. So imagining this is the mind map the student has in mind, I am not going to judge that here. I'm just going to judge the visual of it, because I suppose you'd have your like constructs and the relations between these constructs. I think you'd have them ready depending on your discipline. I'm just using this as an example of, okay, now I have the constructs, they are clear. I have 4 parts that I want to talk about regarding concrete cost, and the student listed the different articles under each was just like a nickname or like a short description of the article, and this was like part of a 2-part assignment. So now what's wrong with this? Beyond the back end, there are a couple problems that we can fix, but let's first look at the different elements, stripping them. Like, I'd like to strip first the colors to look at the different forms separately, and then add the colors, and we'll see why. This doesn't look right. The lines connecting the different constructs are above the constructs. You can just simply make them go behind. It's not really centered. Neither the lines, neither the bullet points of the articles, nothing is really centered, and like the text is all aligned to the left, which is not really suitable for this type of graph. So just a small switch would help things get a lot better, right? Another switch can be using visual contrast to signify the differences between the central idea, which is of course different. It's different here because it's an ellipse and the other parts are like rounded rectangles, but I can further emphasize this using both color, size, and shape. So in addition to shape, I'm also using the color and the size. So both foreground and background color. And you don't necessarily have to like this. I'm not presenting this as the best or the only option to visualize this type of graph. I'm just using this as an example, applying the concepts of visual contrast and consistency. If you get the hang of this, just apply them however you'd like, however you'd see fits your research, but as long as you stick to consistency and understand visual contrast. Okay, so this is not the only way to visualize this. Like who said, you can do this type of figure, for example, and we can do much more. Let's focus on the main topic and 4 subtopics for now. How can we expand on them? And I tell you, you can. We can do a lot of like different design variations, and your figure, much like your research, will not be completed in one go, or shouldn't really. It's an iterative process, like everything we do in life. You do a first draft, perhaps you do the contrasts first. So perhaps before even going through this, I'd say this is a first draft, and it's an acceptable first draft because it's done. The only like objective for a first draft is to be done. It's nothing more. So this has all contrasts in place, constructs in place, or like all the constructs of the methodological diagram, which is the main idea, concrete cost, and the 4 different topics within that. So I have all my parts. I just need to think now about visualization. So by dividing the process into 2 steps, I did the background first, and then I do the visual, or the visualization. I can do it in multiple steps. So for example, first I just make sure it's consistent, and perhaps then I look at the visual contrast, and perhaps look at different variations. So different variations it is. These are all representing what a central topic, and from that like topics stem from this central idea. And it can look in a it can look a variety of ways, like you say. You can make use of composition, like in the top, in all of them really. You can make use of, because it's all compositions. So depending on the shape, on the interlapping or overlapping of the shapes, you create different visual like language. They all say the same thing. Perhaps if I changed the color more, it would say different things as well. You can use the same elements. Mostly all of them are in the same place, only the arrows are different between them. And yet, just by tweaking this, the arrows, perhaps their direction, their curvature, or even their presence, I am having a kinda different image, even though it's the same elements. We can change the elements, we can change the colors, or even use the same colors in a different way. These all are changes of contrast. Perhaps the change that I want to do is not just a change of visuals. Perhaps I may view my topics or subtopics from the main idea. Perhaps I view them as sequential. They relay each other. They move as if like it's a waterfall structure. Or perhaps the last topic relies on the first two. Something like that. There may be a different type of relation, because the relation conveyed in all of these graphs is just a central idea from which we have stuff stemming, right? And this may hold well for explaining a concept or mapping out something, like mapping out constructs or ideas. Perhaps I can further show relations with something like this, where it's just sequential. So construction method follows to material factors, or the other way around. It really depends on your context in this. And then these follow into technology and machine learning. And then finally you talk about cost estimate. Perhaps it's this type of sequentiality is what you are trying to convey. And the way to convey sequentiality is different. Like this figure is, even though it's the same colors, it's the same elements as well, it's just the way you are conveying the same thing. Same as this, it's just a like water just like a waterfall, for example. It can be sequential, and parts of your or some of your topics may be dependent on others. It's not just a straight line. For example, perhaps you talk about material factors alone, you talk about construction methods alone, and both of them feed, or technology and machine learning is both applied on material and construction factors. For example, I can use machine learning to design my mixes or optimize them for performance or cost. Same with construction. So in this diagram in the middle center, I'm not just saying that first, second, third, and fourth. I'm not just sequentially listing. I'm also relaying an almost cause effect. It's not cause effect, but it's like dependency, I'd say. This type of dependency between the different topics is conveyed, and I'm also using different visual elements, which are just icons, to describe the different parts. I am also stretching to an extent the contrast between the different topics, not just by color but also by shape. I don't have necessarily to use specifically arrows to convey that I'm going a certain direction, because this type of contrast going in the figure in the top right, going from construction method to cost estimate, it goes from the further up to the most recent, for example. It shows a direction, it has a direction. And perpendicular to that direction, and this is the part that I spoiled you now, perpendicular to that direction, I may use these arrows or this perpendicular line to describe the different parts that are going on my main direction. It's not necessarily straight, like this last figure, bottom right figure. It also shows a direction. It's almost the same as the top one, but it now has a more curved main line. But still, nonetheless, it has a main line. It goes from construction methods to material factors, to technology and machine learning, and then to cost estimates. A huge important part about graphic design is consistency, like I've been saying. And a huge part, or a huge important part of this consistency is, I'd say, alignment. Alignment of the different objects that you have in your graph to something. Whether they are aligned in a center alignment like these are, or skewed alignment, for example, here. This is a skewed alignment. But if you look at construction method and technology and machine learning, for example, they are aligned vertically. It's not necessarily that you have to align something to another thing along a certain determined axis. It's not that you have to do that, but it's mostly the case that when you do that, it looks better because it's consistent. It has some consistency. If you are able to convey consistency without this alignment, then please do so. But I'd say even these slides are visual elements, are, I'd say, the whole slide, not just part of it, the whole slide is a methodological diagram for me, because I'm conveying something. I'm conveying a central idea and 4 topics in it. I'd say it's a diagram inception or something. So even within that, I have kept to a degree this alignment to a grid layout. Okay? And consistency, for example, all of the white circles or ellipses, are the same size. All of the fonts within the same level are in the same font size and font type. So I have maintained my consistency and alignment to a grid of some sort. Okay, so I'll go over 4 examples or something from articles that I have seen, and let me say, like, this is something that I have developed from like reading, and I'd say like it's the best teacher is reading. because you'll find these types of graphs you'll always find them in literature. And I'd say that in my very narrow field of reading, I'd say, because I haven't read it that wide, different people use it differently. So different circles of research use methodological diagrams in a different way. So perhaps the examples that I'm going to show you, perhaps you may not see them, perhaps you will see some of them, but at the end it's just like the aim of this tutorial is just to give you the cues about foreground and background, to help you identify the different aspects of these methodological diagrams so that you can construct your own in the way that best fits your research. Okay, so the way that I am defining these methodological diagrams, I'd say they are always, or like the way I'm defining them are always like bi-directional. There is always a main direction and there is always an orthogonal direction to this main direction. So there is a sequence of items, not necessarily in a sequential way, but there is a sequence of items along the same level, and perpendicular to that we can expand. And I'll show that in some of the examples that I have used in my tutorial for ACX48. So this is a graph for a systematic literature review where it details the exact procedure that have been done to extract 656 case studies for analysis. This is a really good article. If you are working in life cycle assessment of buildings, you should have like passed through this at some point. But I'm not discussing the crux of the topics here. I'm just talking about, okay, what are the different directions that this graph is going through? And it's pretty apparent. There is a main direction, and perpendicular to that, in a sense, in a figurative sense, it's not necessarily perpendicular that the text is rotated, for example, or it's outside, but it's perpendicular to the direction. Like it's along the width of this main line. I have the description, for example, of like after exclusion I have this many papers. This is a more apparent example of directionality. It's a biased example, but I had it on hand. It's a main direction. It's literally an arrow and perpendicular directions. Perhaps this would have made for a better first example because it's very apparent what they are trying to do here, which is not bad. I'm not saying that is bad. It's great actually that you are able to convey what you want to convey in a very simple manner, visually appeasing, and helps or complements your writing. Okay, now this is a more complex figure detailing a more like comprehensive methodology, a more detailed methodology, but at its core you can always find the main and perpendicular lines. There is always a main direction that a graph is going through, even if it's not a standard flowchart. It's going from somewhere to somewhere, and this is the way to unpack these types of graphs. So if this will help you actually read in whatever literature that you are reading, because you can break down these types of complex figures into their parts, unpack them, and look at each part separately, because now I know it's easy for this graph, for example, because it's using visual contrast in a way, because I have delay risk identification, for example, is the title for this block, and under that I have these different blocks, many or like subtopics or sub-processes that I do under delay risk identification, and then I go to the next stage, and then sub-stage, and then the next stage, and so on and so forth. So I can read this graph in like two zoom modes. For example, I can read the headings and go with the main line to understand, okay, they did this, and then this. Or I can zoom in to a specific thing like data pre-processing to understand, okay, what did they do? Or what did they have in this? Okay. So it actually makes reading articles pretty easy, or like easier. Okay, so this is a more visual, in a sense, example where specimens are prepared for a type of concrete. Um, it's also very directional, and it shows the main and orthogonal direction. I can see materials that are prepared to be dry mixed for a certain time, then adding part of the water, then mix again, and then I go along until I have my specimens. This is a very similar graph, also using illustrations, because you can, like, who said you can't? You can use it for sure. And it's going in the same direction as well. It's going this way and then this way, and there are perpendicular information conveyed, which represent, for example, a more an expansion of what are the inputs, outputs, what are the different components of this, for example, life cycle, from the beginning raw materials until the finished product. This is another life cycle example. This is what I'm working on at the moment, so I have a lot of examples from there. This is also a pretty like foundational article that I'm using here. Also, if you are working on life cycle assessment, you should read this. But this is not the point. It's pretty solid in its showing the main and orthogonal directions. It's not necessarily orthogonal meaning 90 degrees, it's just going on a direction different than the main, like orthogonal to it, to expand. It's like the width of the main line, kinda. And it has made good use of visual contrast. It made good use of the spatial location of parts. So using the concepts that we have talked about, we can unpack this type of graph, which looks really good, conveys its message clearly, and complements the actual writing. Okay. So this is the last example. This may look a bit complex, but if we unpack it, we'll find it's the same thing. You have a main line, and based or like orthogonal to it in some sense are supporting information. So this is the lifetime. This is like the main line here is like a timeline of processes, or the process diagram of a system, where it starts from raw material, goes to transportation, construction, use, demolition, second phase of transportation, and then end of life. Orthogonal to that, we have two types of energy. We have embodied and operational energy, and each type of energy, embodied energy, contributes to most, like basically every part of the life cycle process. Operational energy mainly contributes to the use phase of a building. Now we have unpacked as well this figure by identifying the main directions. Now let's go back to this figure. Like we said, there are grids to be obeyed. All of these figures are on the same grid, or all of these small rectangles, are obeying this grid. For example, this line, I don't know if I can, yeah, I can. This line, for example, is not on the same alignment here. So one would perhaps like to put it in the middle. One would also like you may say, well, it's you may break intentionally order or grid or consistency, but if you break order, you break consistency. If you break consistency and your figure is not coherent, you may like it may not be effectively communicated to your readers, so you may not, or you shouldn't really do that. Looking at the second example, this is well a grid, or well aligned to a grid, for example, like the lines and these parts in the top, at the top, are pretty much centered at the, like with respect to the parts at the bottom, for example. The heights of these parts are all equal. I mean, the researcher is also using the same like formatting for each item, or for example the text within each of the same levels. So like this is the same Times New Roman, this is the same Times New Roman, this is bold, and this is as well bold. So there is consistency to making this type of figure. So both in a grid, for example, there is also another consistency here where this line of this like part of the flowchart goes kinda in half, or like, because I have two things going into one thing, so they also aligned it. These visual cues may look silly, simple, but the like accumulation of these, the amalgamation of these, is what gives your compositional contrast and what makes your figure look good, actually. So it's really important to nitpick at these things. Okay, so the last part of this video is to build the very first graph from scratch. Not everything about it, but I'll go to, like, let's say 50% of what's been done, because I am not interested in this video in the actual technicalities. You can draw this figure using PowerPoint. I didn't. I used what's called draw.io. It's an online free platform. I used it. You can also use PowerPoint. You can use like many tools to draw this type of figure. I'm just interested now in the composition. Okay. So the figure that I've shown in the beginning describes the calculation of embodied environmental impact in a wall, a masonry wall, which is made up of concrete masonry units. It's made up of clay brick. It's made of grout and mortar. It's made of steel reinforcement. So summing the impact of each of these components would give me the total impact of constructing the wall. And to calculate the impact of each constituent, so the bricks alone and the blocks alone and the grout alone, I need to calculate either the mass or the volume of each constituent and multiply it by an emission factor. This is the easiest way to describe this calculation. So I want to visualize this, which is basically this last equation here, which is summing these parts gives me environmental impact, which equals each mass, or volume really, this should be volume, multiplied by an impact factor, because it can be kilogram CO2 per meter cube or kilogram CO2 per kilogram of material. Okay, so let's try to visualize it in a very like basic sense, using even like this is smart art from like PowerPoint. It's nothing new. I'm not recreating anything. I'm just using the constructs. So I have bricks plus grout plus mortar plus steel reinforcement gives me environmental impact, and this is the main axis of my narrative, of my logic. And perpendicular to it, I may perhaps talk about how to calculate each of the different parts. Perhaps talking, like having the orthogonal direction in this vertical may not be optimal for me. So I may try to flip the axes to start talking. This is what I just did. I just flipped the axes. So now I can talk about bricks and expand in this direction. So I can talk about bricks to calculate the volumes of bricks using effective solid ratio. I can calculate the volume of grouts and volume of mortar, and using these volumes I can calculate the mass if I needed mass using the mix design or the recipe for these mortars and grouts, or using the total density. If I have the density of my grout and I have the volume, I can get mass. Same thing with steel reinforcement. I can get it from the rebar size and length. It's steel, so it's constant density, so I have volume and density. I get mass. Now what I just described is secondary to the idea. I just told you for each brick, grout, mortar, steel reinforcement, for each of these, I've talked alone about how to calculate its portion. But the main idea is summing these portions, giving me the environmental impact or embodied impact of a wall, which is just summing the quantity multiplied by the factor for everything. Now I have finished, in a sense, my back end. Perhaps I may just write equations here and there just to indicate each part, but this is really the back end that I have, right? I described the equation, I described each part of the equation, and it being the summation of these parts and describing each part. So I can just start adding my contrast, perhaps a visual contrast using color. Perhaps I'd add more details for each. Perhaps I'd add the equations, perhaps I'll use some indicative language to describe the different parts of the equation, and now I have my full graph. So the point going from here to here is just your visual choices, from which I'll just tell you be consistent. It's the most important part, is to be consistent, and that's it. Be consistent and try to make use of visual contrast in a way that does not break your consistency. So do not use, like for example, a red background here. You cannot use a red background here to say, well, this is contrasted. Yes, for sure, it's contrasted, but it breaks what you have. It breaks your consistency. Okay. It breaks the color palette. It's not really there if it's like a very harsh yellow. Okay. So this is the end of the video. I didn't anticipate it having I didn't anticipate having to spend 50 minutes on this, but I am glad to have recorded this. These are additional resources you'll find in the description of this video. This is the fundamentals of graphic design, a specialization on Coursera about graphic design. You don't have to do this. Perhaps the very first course of this specialization may give you more like information description about what I talked about: visual contrast, connotation, typefaces. This is a color wheel, simple color wheel. Just go play around with it. Also explore with color palettes. It's a good way to look at things. And yes, one thing is, let me tell you a secret. These are all the same color. I'm just using different transparency levels, and this is how they are kind of homogeneous, because it's the same color. I'm just using different like transparencies, so it's homogeneous. It's monochromatic. Yeah, so this part is good for talking about using Illustrator. Adobe Illustrator is a more sophisticated tool for drawing scientific diagrams, not just drawing the methodological diagrams, even the icons or the illustrations perhaps of your setup, test setup. You can do this using Illustrator and it will look really good. And like, I really recommend this playlist. There is a guide on mind mapping, which is good for research. Both of these are good mind mapping guides. This is just to the point mind mapping. This talks about mind mapping in scientific research or as a research and writing tool. That's all for me. That's all for now. That's it.